Hello and good evening, friends of Sudoku. It's evening here. It's 9:30 p.m. and I solved this puzzle on paper about half an hour ago, and I thought it would be a very nice instructional Sudoku to show those of you who still struggle with how to solve Sudokus, and in particular how to solve Sudokus without using notation. I mean, this is so easy to solve with notation. I will make a few comments about that as I go along. And because I thought it would make a very good example of how to think about how to go about analyzing and thinking about a puzzle as you would attempt to solve it. So if you want a very complex and a difficult puzzle, this is not it. It looks complex and it can be difficult to find the first digit even. But I think that some of you will find it pleasing because of the logic that you employ to solve this puzzle. So without further ado, I will show you how I think when I solve a puzzle like this. And I have to admit that it does require a certain degree of experience to train yourself to think like this. But once you do, and you see how easy it is to solve a hard puzzle. This is a Chinese-made so-called hard puzzle with a target solution time of about 32 minutes. I solved it on paper in less than 10 minutes. And that's not because I'm particularly good or intelligent. It's just because I found the tricks. And those aren't even tricks. They're just simple Sudoku tactics and strategies that anyone can employ. So without further ado, let me tell you what I did as a beginning. I looked at the 1, 3, and 4 here, and I saw that they block here. It really doesn't take an expert to see that, but it means that these three squares must be a 1, 3, and a 4 in some combination. Of course, this square here can't be a 4 because it blocks, but that is besides the point right now. So I just saw the 1, 3, and a 4 blocking, and therefore these are 1, 3, and a 4. My immediate thought then was to say, okay, if these are 1, 3, and a 4, what then are these? And they happen to be a 2, 5, and an 8. That still doesn't give me a digit. But the mere fact that these two squares now are blocked by a ghost 2 and a 5 that will be in two of these three cells. And I see the 2 and a 5 blocking down here. I now know that these two squares must be a 2 and a 5. And having had that revelation, I immediately see these two 5s. They are blocking down here. And these have to be a 2 and a 5. And because of this block here, this must be the 2 and this must be the 5. Once I enter the 2 and the 5 here, I immediately look upwards and I see all of these squares blocked by this 2. I see these squares blocked by this 2. And I know now that I need to have a 2 in one of these squares here. I can't place them yet, or I can't place any 2 here yet, but now it's in the forefront of my memory and I don't have to look at that again until I find a 2. Next, because I was so focused on the 2 and the 5 and the 2 and the 5 and the 2 and the 5, I completely overlooked that these two 4s block here. And therefore, this must be a 4. But this is the next thing that I noticed. The next thing I notice is that an 8 can't go here, must go here or here. I also noticed the 3. The 3 can't go here, so the 3 must go here or here. So now we have a 3 and an 8 pair. I can't place the 3 and an 8 yet, but now I know that this square and this square have to be a 1 and a 9. But since we have a 1 in this block of 3 by 3 squares, this must be a 9 and this must be a 1. So now I only have to deal with 3 digits to complete this block here. And the next thing I do is I start thinking about what they can be. And they have to be a 6, 7, and a 9. I can't place them yet, but I will try to keep this in memory, even though this bend pattern for 3 digits in one block can be difficult to remember. But it will be very easy for me to reconstruct. I just need to see those other digits to see what's missing. And if I need a reminder about the 9, I just have to look at these 2 9s they block here. So these are the initial easy digits, but there is more, because now I start looking elsewhere in the grid. I've been focused on this bottom shoot. Now I see the 5 here and the 5 here. They are blocking over here, and that makes this a 5. We know, by the way, that we have a 1 and a 3 here because we had the initial 3, 1, and a 4 going down here, right? The 4 is already spoken for, so these must be a 1 and a 3. And we know, of course, that these have to be a 3 and an 8 because I just said so, and we have established that it was quite easy. I now know that one of these squares must be a 9. And how do I know this? Well, this 9 blocks up here. This 9 blocks over here. So one of these two squares must be a 9. Therefore, these squares can't be a 9. This square blocks these 3 cells, and therefore one of these is a 9. So after I found this 5, I looked at the 4 blocking over here and the 4 blocking up here. So this is a 4. Now I know that one of these must be a 4. I also know that one of these squares must be a 9. I know this because this square is blocked by this 9, and we know that for this block here, one of these must be a 9 because we just established that fact. So this can't be a 9, this cannot be a 9, this cannot be a 9, therefore one of these two must be a 9. And while I'm thinking about that, I spot the 2 3s here blocking all the way over here, these 6 squares, making this a 3. And remember how these two were a 1 and a 3? Now the 3 blocks down here, making this a 1 and this a 3. And I have to tell you that if you only concentrate on digits, and I know that many people do that, all you will see is those digits. Sometimes it will help you find a missing digit somewhere. But I prefer just counting. For example, if just looking at these 4 empty squares, you don't really see which digits have to go where. But if you start counting and saying, well, we got a 1, 3, 4, 8, 9, what's missing? Well, missing are a 2, 5, 6, and a 7. Now you look down here, 2, 5, 6, all block this square. Therefore, it must be a 7. And these two 7s now block here, making this a 7. These 3 now have to be a 6, 8, and a 9. Of course, the 6 can't go here, so a 6 must go here or here, and therefore one of these two squares must be a 6. And this is where our memory gets into play. Let's look at, we know that one of these is a 6, right? So let's focus on this square here. What else is missing in these 3 squares? Missing is a 1, 2, and a 5. So a 1, 2, 5, and a 6 are missing from these squares. Okay? this blocks here, so this can't be a 1 anyway. But now remember that we had a 2, 5, and an 8 over in these 3 cells. So a 2 and a 5 block here. The 1 blocks here as well. So the only digit that can go here now is a 6. And that makes this a 6. And remember how these are a 3 and an 8? These two squares now must be a 2 and a 5. So we're moving on. Look at the 6 blocking over here. Look at the 6 blocking up here. We know now that one of these must be a 6. So all of these squares are blocked by 6's, and these squares are blocked by 6's, and this 6 blocks this square, making this a 6. One of these now must be a 6. And given that there cannot be a 6 in any of these 3 squares, we now must find a square for a 6 in row 3. Since one of these must be a 6, none of these can be a 6. This 6 blocks this square, therefore this is a 6. These now have to be an 8 and a 9. And besides the 8 and the 9, we still need a 2 to complete this row. And there's a 2 blocking here, so this is a 2. So now this is an 8, 9, this is an 8, 9, and this is an 8, 9. I think that this grid here is a very good example that can be used to demonstrate the various simple logical techniques that can be used. The simple techniques that only require logic and a little bit of short-term memory. The next thing we notice is that we need an 8 for row 4. The 8 here blocks this square, and the 8 here blocks these squares. This 8 blocks this square, so this is an 8. And remember how one of these is going to be a 9? Now we have two 8s here, making the other one an 8. So this is now a 9-8 pair. And remember how one of these had to be a 9? The 8 now takes away one square from the 9 candidates. Therefore, this must be a 9. And that makes this a 9 and this a 7. These being 8 and 9s, and this 7 blocking up here makes this a 7. This, by the way, is not from memory because I can't possibly remember how to solve an entire grid, even if it was an hour ago. So this is something that I'm just solving on the fly. So you can see how easy it really is. Now we got these 7s blocking up here, and we got the 7 blocking over here. So this is a 7. And believe it or not, I still haven't found all the digits of just one digit. For example, a 7 is still missing, but I think I find it now because these cells here are blocked by 7s. So this must be a 7. And yes, that was the last 7 of the grid. And these being 8 and 9, that makes this a 4. This 4 blocks over here. This 4 blocks up here. This 4 blocks down here. So this is a 4 for row 5. And this, therefore, is a 4 for column 1 and row 3. So 8 and 9, this can't be a 4 because we have a 4 blocking in the row. So this is a 4, and this has got to be a 6. Now we got all the 7s and all the 4s. This 1 blocks here. Therefore, this is a 1, and the last digit must be a 3 in this block 5. So we got a 3 blocking here, and a 3 blocking here, and a 3 blocking here, making this a 3. Now we need a 1 and a 5 for these two squares, and I don't have them yet. But I have a 1. Yes, I have a 1. Because the 1 blocks over here, and this 1 blocks up here, so this must be a 1. And therefore, this must be a 5. The 5 blocks down here, we know that one of these, no, we know that these have to be a 3 and an 8. And since the 5 blocks down here, this is now a 5. The last digit in this row has got to be a 2. And therefore, this digit is a 1. These 3 empty squares must be a 2, 3, and a 9. There's a 2 coming down here, so one of these is a 2. Oh, yes, 3 and a 9 going across here. So this is a 2 and this is a 3 and a 9. And therefore, this must be a 2. These two squares must be a 6 and a 5. We have a 5 in this column. So this is therefore a 6 and this is a 5. And remember how we had 2, 5, and an 8? Those were the first digits we found almost in this grid, and we can now solve some of them or all. So we have a 5 and an 8 blocking down here. So this is a 2. And this is now a 5 and an 8. And we have a 5 blocking here. So this is an 8 and this is a 5. This last digit must be an 8, making this an 8 and this a 9. And this must be a 9 now and this an 8. Because we already knew that these 4 digits had to be 8s and 9s. These two cells must be a 2 and a 6. We got a 2 in this column, making this a 6 and this a 2. And these here now must be a 9 and a 1. We have a 1 here, making this a 9 and this a 1. 4 digits missing, a 3 and an 8 down here, I remember, and we have an 8 now blocking down here. So this is 3 and this is an 8, making this a 3, and this must be a 9. So this was just a simple walkthrough of a hard Sudoku. I didn't classify it, the Chinese did. But if you're not used to solving Sudokus without a notation, or if you're not that experienced yet, you might have found it hard. So what I hope is that I demonstrated how relatively easy it is to solve these puzzles by just using standard logic and reasoning. I hope you enjoyed it and that you'll come back for more soon. Thank you for watching and bye for now.